Hello everyone, welcome to another video. So in this video we'll be solving jump game. So in this question what we are given is that we are given a vector of nums in which we have to reach from the first index to the last index, and from jumping from one index to the other we are given a nums of a number at the ith index, and we can jump at most I plus nums of I. So by doing this at every index or not at every index, we have to reach last. So we have to find we can reach at last or not. So let's see at example 1. So 1 plus 2, so we can reach at I plus 2, that is at 1, and 2 plus 1 we can reach at 3, 3 plus 1 we can reach at index 4. So yes, we can reach at index 4, and in this second example we cannot, so we have written false. So the approach would be we can reach the index from I to n. So we can also reach the index 0 from last to first. If we can reach from first to last, then we can also reach from last to first. So the approach would be we will try to reach the index from last to first. If we can reach the index from last to the first, so the answer is yes. If not, then the answer is no. So let's see. We can what we will do, we will check at index I that if we can reach to the last index or to the index. So what we will do, we'll let's see here, we'll create an index last in which we'll assign the value n, and I will check at the ith position if I can reach the last or not. Let's see, I plus nums of I is greater than equals to last or not. If I can reach from the ith index to the last index or not. If I can reach the last in, if that I can reach from that index to the previous to the next index, so I will initialize the last to the I, and I will check for its previous index if I can reach from the I to the current index or not. So it will be very clear from the code. And at last, if the value of last will be 0, then we can reach at the first index, and if the value is not equals to 0, then we cannot reach at the last index. So let's see, we'll create a index int last equals to nums dot size minus 1, and I will run a loop from int I equals to nums dot size minus 1 I greater than equals to 0 I minus 0. If currently where am I at? I am at the last index. If I plus nums of I is greater than last, if I can reach beyond the last index, or if at the equal to the last index, then I know that I can reach from this current from the current index to the last index. So we'll initialize last equals to I, and by doing this for the all the elements, I will check if last is equals to 0 or not. If the last is equals to 0, then I can reach the first index. So let's see it for the test case. 3 2 1 0 4. So last equals to uh, what is the 0 1 2 3 4, last equals to 4. So the last index is 4. So what I will do, if what I will check from the current index that I can reach the last index. 4 plus 4 is greater than equals to 4. So I know that I can reach to the last index. So the last will be equals to 4. And I will come to the previous index, and I will check if 0 uh, 3 plus 0 is greater than equals to 4 or not. But it's not. So I will continue to the next index. I will reach at index I equals to 1. So what I will do, I will check 1 plus 2 is greater than equals to 4. No, it's not. So I will check to the last index. Is 2 plus 1 greater than equals to 4? No, it's not. And at last we will check for the index 0. Is 0 plus 3 is greater than equals to 4? No, we can't reach at index 4 from the previous indexes. So the last value will be 4. So we can't reach, so the answer will be false. So here you can see at the example 2 the answer is false. But let's see for the example 1. 2, 3, 1, 1, 4. So last value is equals to 4 because we are at the last index, which is 4. Then I will check if 4 plus 4 is greater than equals to 4. Yes, it is. So our last value will be 4. And this is at index 4. At index equals to 3. The last will check if 3 plus 1 is greater than equals to 4. Yes, it is. So our last will change to 3. Now I will check at index 2. Is 2 plus 1 is greater than equals to 3? Yes, it is. We can reach the next index from this index. So last will be equals to 2. From the index 1, can I reach index 2? We'll check. 1 plus 3 is greater than equals to 2. Yes, it is. So we can reach the index. So our last value will be equals to 2. Last value will equals to 1. And at index 0, can I reach index 1? So we'll check. 2 plus 0 is greater than equals to 1. Yes, it is. So our last value will be equals to 0. I can reach the index 0. So here I have reached from the last index to the first index. So the answer will be yes. So we'll return true. So as you can see, the first example returns true. So let's submit it. The time complexity with this solution is big of n, and the space complexity is big of 1. So let's just submit it. Boom, it got submitted. Thank you for watching.